Okay, so we've done law of sines. Now we're going to do law of cosines. Okay, and on the law of cosines, first we want to talk about when do you use that to solve. Now, we're still solving in law of cosines. We're still doing oblique triangles. So, the law of cosines is also used to solve oblique triangles. You can simplify that. Okay, so that means it still has a triangle without a 90-degree angle. Okay, and there's basically two times you're going to use law of cosines. One is if you're given two sides and an included angle. Okay, so that's like in geometry we call it side angle side. Okay, or if you're given three sides, then you can solve for all the missing angles. So that would be like side, side, side in geometry. Okay, and let's go through the actual law of cosines, the formulas. Okay, the law of cosines says a squared equals. Okay, now look up here for a minute and listen to what I say. A squared equals the sum of the squares of the other two sides minus twice their product times the cosine of the included angle. Okay? Let me say it again. A squared equals the sum of the squares of the other two sides minus twice their product times the cosine of the included angle. Okay? And you may want to write that out. Okay? A squared equals the sum of the squares of the other two sides minus twice their product times the cosine of the included angle. Okay? So now, to write the other two formulas, b squared would equal, okay, the sum of the squares of the other two sides, so a squared plus c squared, minus twice their product, 2ac, times the cosine of the included angle. So it would be cosine of angle B. Okay? And the last formula, c squared equals sum of the squares of the other two sides, and they're going to write it a squared plus b squared, minus twice their product, 2ab, and the cosine of the included angle. Okay? So that is the law of cosines. Okay? Now, we're going to stop for a minute. I want you to write these on your card. And I also want you to put, when do you use it? You use it for side angle side and side, side, side. Okay? Let's stop. And we're still doing oblique triangles. Okay, and this is similar to on law of sines. If you look at this, we're using cosine of an angle. By definition, cosine is adjacent over hypotenuse, but we don't have a right angle. Okay, so how do we get that in there? So I'm going to go through the proof I'm not going to grade you on the proof, but I do want it in the notes. I think you need to go through some of this to figure out where does this come from. So put this in for the proof of the law of cosines. Okay, and first we need a picture. We're going to do this on a coordinate axis, so draw a coordinate axis. Okay, and draw a triangle like so. Okay, label this point A and the ordered pair XY. Label this at the origin, label that B, and that would be 0, 0. Label this C, and that would be the ordered pair. And we're going to go this, since this is angle A, this would be side A, so this would be A to the right and up 0. Okay, this would be side B for this triangle. This would be side C. Okay. On this, let triangle ABC be an oblique triangle with the vertex B. Let triangle ABC be an oblique triangle with the vertex B at the origin. What we want to find is the distance from A to C. So I'm really looking, I'm going to prove the middle one up here. I'm going to prove this one, the B squared. Okay? Okay. To do that, we drop a perpendicular. You got to get a perpendicular in there somewhere. Drop a perpendicular from A and make this a right angle. Okay, label that point would be point D. Let's label this would be X from the origin to the left, and then this would be our Y. Okay, so point A is our XY. In triangle ABD, okay, what's the sine of angle B? In triangle ABD, sine of angle B, opposite over hypotenuse would be what? Opposite would be y over c, right? Okay, and then cosine of angle B, that one would be your x over c, adjacent over hypotenuse. Okay, now if we multiply and solve for y, multiply by c on both sides, then you'd get c sine of B equals y. On this one, if you multiplied by c on both sides, you'd get c times the cosine of B equals x. So that means this xy becomes c cosine of B and c sine of B. Okay? xy is now c cosine of B and c sine of B. Okay? Now, key word in this whole thing, what we want to find is the distance between A and C. Well, now we've got two ordered pairs. So you find the distance. Okay? So, use the distance formula. Okay, distance equals. Okay, remember distance formula is a square root. Okay, and extend that radical out. It's x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1 quantity squared. Make sure you can read your own handwriting, that those are subscripts and these are exponents. Okay? And now, we're trying to find the distance, and our distance is actually b. Okay? And it's the square root, and I labeled this as my x sub 2, y sub 2, and I labeled this as my x sub 1, y sub 1. Okay, so when you sub in, my x sub 2 is going to be c cosine of b. My x sub 1 is a, quantity squared, plus my y sub 2 is going to be c sine of b minus 0, quantity squared. Extend that radical out. Okay. Get rid of the radical, square both sides. If you square both sides, this becomes b squared and that radical's gone. Okay? And then all we have is c cosine of b minus a, quantity squared, plus c sine of b, quantity squared. When you square a binomial, remember you're going to get a trinomial square. So you'd have b squared equals. Shortcut is square this first term. When you square that, you square the coefficient. So you square the c squared. You square the cosine squared. Multiply the c cosine b minus a. Multiply those together. So it'd be a negative ac cosine b and double it. So you'd have a minus 2ac cosine b. And then square the last one, be plus a squared. Now, if you can't do it by that shortcut, you actually write it out and FOIL it out. Okay? And then plus, now square this one, you square the coefficient, so it'd be c squared. Square the sine, so it'd be sine squared b. Okay? Now it's a matter of commutative property, rearrange terms. Okay? Remember when we did this, it was the sum of the squares of the other two sides, so put the a squared first. Okay? And then put the plus c squared cosine squared b plus c squared sine squared b, and then minus the 2ac cosine of b. Okay, and now look at these two terms. What's in common in those two? C squared, right? There's a c squared here and a c squared here. Factor that out. Okay, so if I factored that out, I'd have b squared equals a squared plus c squared. And what's left out of this one would be cosine squared b plus sine squared b minus 2ac cosine of b. Okay, but what's this? What's sine squared plus cosine squared? 1. Okay, so you'd be at b squared equals a squared plus c squared times 1 minus 2ac cosine b. And you end up with the law of cosine. And that's just proven one of them. But I think it's important that you know where some of these things come from. Okay? Okay, now let's go through an example. Okay? Let's go through an example. Say you're given angle A is 40 degrees. Side B is 10. Side C is 20. Okay, find side A to the nearest tenth. Okay, now the author is going to mix these up. Now that you've had law of sines and law of cosines, the author is going to mix them. I would always still put the angle you know in the lower left-hand corner, so that matches our other notes. So we know that angle A is 40. Okay, we don't know side A, so it doesn't matter on this. One of these is 10 and one of these is 20. So we're given side, angle, side. You may want to highlight that. Okay, so you're given side, angle, side. so it is law of cosines. Okay, and they want you to find a. I do want you to write the formula down. So you'd have a squared equals the sum of the squares of the other two sides, b squared plus c squared, minus twice their product, 2bc, times the cosine of the included angle. Notice the included angle is always the same as that side, so cosine of a. Okay, so sub in a squared equals 10 squared plus 20 squared minus 2 times 10 times 20 times the cosine of 40. Okay? Now, you should be able to just punch this in, make sure you're in the right mode, check your mode on your calculator. Degree mode, and I'd go the 4 decimal places so you know. Okay? Okay, so just punch it in. 10 squared plus 20 squared minus 2 times 10 times 20 times cosine of 40. Okay, and I get 193 something. Do you get that? 193.58. Okay, now they want a. You've got to get rid of the square. So now you're going to take the square root. Okay? Okay? So take the square root of that answer. Don't type in 193.6. Do second function answer. You don't want to round on these, on any of these, you don't want to round until the final answer. So I get 13.9. Okay? Now, if they take it an extra step and say, now find an angle. Okay? Let's say now they say find angle B. Okay? If I'm going to find angle B, I need to store this. Okay? Just so I've got it. So store this answer as, this was side A, right? So let's do alpha A. So I've got that in there. Okay, to do the angle B, okay, you've got to go back now to the law of sines. Okay? So you got to go A over the sine of A equals B over the sine of B. Okay? Notice on this one, I always said don't use something that you solve for. Well, you're going to have to. So if you made a mistake on the first one, it's going to be a chain error. So you want to be careful when you're going through it. Okay, so we've got our A over the sine of 40. Now, don't type in 13.9. We're going to use the stored value on the calculator. B is 10, and sine of angle B, we don't know. Okay, so we need to take, now, and I would do this in this order. I would not do sine of 40 times 10, because that creates, it looks like you're doing sine of 400. Do 10 times the sine of 40, okay, 10, and then sine of 40. And then you want to divide by our alpha A, right? Okay. So we got the sine of B equals do you agree with that? 0.4620? Yep. Okay, now you know the value of the function. You don't know the angle. So that's when you do inverse sine of that answer. Okay, and angle B then is 27. If they go to the nearest tenth, be 27.5. Okay. Okay, so you may end up using the law of cosines, but to solve for an angle, law of sines. Okay. Okay. There are 3 other formulas. Okay, and they're actually in your book, but I'll put them up here too. Look in page 170, right about in the middle of the page, and I'll put them up here too. But if you need it, if you don't, they are right here in the middle of the book. Okay, and I'm going to give you a handout of when to use these. Okay. Okay, if you're solving for an angle, maybe I should do the handout first. Hang on. Okay, if I go back up here and I take these three formulas and I solve for the angle, okay? So now add these to your card, okay? So that's when you're doing law of cosines, and if they give you three sides, okay, you find the angle opposite the longest side using the law of cosines. Okay, so here's the okay, so add these. It's on page 170 in your book. Cosine of angle A equals b squared plus c squared minus a squared, and it's all over 2bc. Now, the critical part about this, on your calculator, you have got to say, I'm taking that top part divided by the denominator. So make sure you emphasize the parentheses. Okay, same idea if you're trying to solve for angle B. Okay, it's a squared plus b, excuse me, sorry, a squared plus c squared minus b squared, and it's all over 2ac. And make sure you put parentheses here and here on your card. And then you would do, when you get cosine of B, then you would do inverse cosine and solve for the angle. Okay, and the last one, cosine of C is a squared plus b squared minus c squared, and it's all over 2ab. And make sure you emphasize you got to have those, otherwise it will mess up on the calculator. Okay, so that is on the three sides. If they give you three sides, you find the angle opposite the longest side first. And remember, longest side is opposite the biggest angle. Then find any other angle using the law of sines. Then find the third angle by subtraction. Okay? Okay.